So I'm Fabian Schüssler. I'm an astrophysicist at CEA in Saclay, outside Paris in France. And I'm co-leading one of the work packages that Antoine just mentioned within the ACME project. Within my daily work, I mainly work on high energy astrophysics and time domain phenomena. And for that, we developed one of these platforms that we'll introduce in several talks this morning, called Astro-COLIBRI. And I'll just mention here that it's a whole team of people, and we have a few of them connected and giving detailed talks about various aspects of that platform. So my role is just to introduce the topic, introduce the aim of the platform and the science we aim to do with that, and the science we aim to do together with you as the, again, Amateur Astronomers, Citizen Science, whatever you want to call yourself. So let's dive into that. So it's an app, it's a platform for real-time follow-up of transient sources. And I take a step back and try to introduce these and also introduce the concept of that has been mentioned, which is at the core of the ACME project, this new way of doing astronomy, this multi-messenger astrophysics way. So what are transient sources to start with as a very high level view? These are just rapid temporal phenomena which can last from seconds to days, maybe weeks, and typically are hints of explosive, very high energetic events in the universe. There's a whole list of these, and I guess we could spend at least an hour or two on each of them, why they are interesting, what science we can do with them, what we can learn about the universe, about these explosive phenomena by studying, by observing them. I certainly don't have the time to do so. Just believe me, there's a lot of things that we don't understand yet, and there's a lot of more data that is needed to really grasp what's going on in details in these violent events. What they all have in common, that they emit across the electromagnetic spectrum, from the radio to the highest energy photons in gamma rays. And now this new way of looking at the universe, they mostly also emit neutrinos, cosmic rays, and gravitational waves. So these are new messengers in addition to photons, so light, that are emitted by these sources, travel through the universe and can be detected on Earth. And by detecting all of them and by combining the information from all of these messengers, we call it multi-messenger and multi-wavelength astronomy. And that's what we are doing as a professional astrophysicist, and that's at the core of this ACME project, and that's at the core of the Astro-COLIBRI project and what we are going to talk about today. And why do we want to do that? It's just to get a complete picture of the phenomena that we are studying. So the more information, the more observations we have, the more we can spend these various multi-wavelength ranges, these various messengers, the better we can understand and model with theoretical understanding these events and the processes that are involved. So how do we observe these transient phenomena, these transient sources? So just focus on the electromagnetic spectrum, on photons, again going from the radio through the very important visible domain up to high energy gamma rays. And there we have a large range of observatories on ground and in space that are monitoring the sky, constantly searching for new emissions, new sources popping up at a random place at a random time. So these are these all-sky surveys that scrutinize the sky and give us the information something new has happened at this place at that time. But typically, these have relatively low resolutions, both in position, in energy, in timing, etc. They only detect the phenomena in the first place. Of course, this is not only happening on the electromagnetic spectrum, but you also have very fancy instrumentation at the South Pole, for example, detecting neutrinos. We are also building one of these neutrino telescopes in the Mediterranean Sea currently. And then you have these large laser interferometers detecting gravitational waves, so these ripples of space and time. And these also give you a rough identification, something new, something interesting has happened. But then to really understand these phenomena, you need follow-up observations. So these are pointed observations. Again, here a few examples of large professional facilities that I guess you have all heard about, at least the James Webb Space Telescope. And these provide then detailed information with high resolution, but of course very small sky coverage, so you have to tell these telescopes where to point. And the connection between these two is where our platform, so the Astro-COLIBRI platform, comes in, because we want to improve and facilitate the connection between the detection, the observatories detecting a new phenomena, and then these detailed follow-up observations, which allow to do most of the science we are after. So I'm talking about time domain, transient phenomena. So the question is always, how fast do you have to be? What's the time scale involved? And this is a very broad question, because it really depends on the phenomena. They cover, in the radio domain, you have fast radio bursts, so eclipses of very strong radio emission that only last milliseconds. Then you have gamma ray bursts, which have an optical afterglow that you see here, which decreases very rapidly. You see the magnitudes here. So this is 13, 15. And then very early on, so these are seconds and minute timescales, and then after days you reach you're down to magnitudes of 20, 22, 23. So these are phenomena which you have to catch very rapidly. You have to have your procedures very well tuned to be able to observe them. But this is not all. There are many more phenomena where you have a more relaxed way of catching them. Prime examples are, of course, supernovae explosions, where it's still very interesting to get this early rise of the light curves, which rises depending on the type of the event over a few days. But then they fade away over weeks and months. And there, continuous monitoring is extremely helpful to see these color changes, to see these wiggles, these plateaus, these breakouts, things like that. And this is clearly something where we struggle with professional instrumentation, because we don't have the time available on these large telescopes to observe a source for very many days, many weeks continuously. And this is one of the domains where citizen science and amateur astronomy can really contribute tremendously. So timescales vary, again, from minutes to days to weeks, depending on the phenomena that you are after. So then again, we need to know where to point, and we need to be fast. So if you want to point in a few minutes, in a few hours, you have to get the information rapidly. And therefore, we have developed this platform and this app that is trying to facilitate all that. So that's the whole aim of the Astro-COLIBRI platform. So how does it work in practice? Again, a new flowchart. You have all these astrophysical phenomena. GRBs are these gamma ray bursts, high energy emission from an exploding stars. Then you have the supernovae, for example, typically detected in the optical with these longer time scales. So these occur at a random place at a random time, emitting all these messengers like photons, gravitational waves, neutrinos, and cosmic rays. I've mentioned these monitoring observatories. These detect these emissions, and at least one of these messengers, and then send alerts. These alerts go traditionally through a variety of what we call brokers and streams. So there are various different platforms and tools available to alert the community. All of them, unfortunately, use different data formats, different ways of communicating this information. But then most of the large professional observatories listen to this stream of alerts and information and react mostly automatically or semi-automatically. So we have machine learning tools or AI in place, but also humans in the loop to sift through that wealth of information and pick the most interesting ones and then conduct these very interesting follow-up observations. But then, of course, these streams and data formats, I think that are rather tedious and difficult to use. So that leaves the amateur astronomical community out of the picture. Not to talk about the general public who just wants to see what's going on in the sky at any given moment. And that's a pity. So again, these alerts are coming in various formats, XML files, JSON files, some are distributed by emails, etc. So are difficult to read and often not really accessible if you are not within that community and subscribed with a professional email address, etc., etc. And combined with that, over the years, the professional astrophysicists have produced a huge variety of tools and platforms and databases where you can find information about these events, but also about the context, about known sources at the same region. You have a supernova going off, you want to know about the host galaxy, how far is it away, what's the type of the galaxy, etc., for example. But these, again, are scattered throughout the internet, hard to find and often quite hard to use if you're not used to them and on a daily basis. Come in Astro-COLIBRI that we have developed over the last 5 or 6 years now, as a top-level tool, collecting all of this information in one place and making it accessible in an easy-to-use way. So we are listening to all of these incoming data streams. We collect it in a database that we make available, and we provide detailed links and direct links to all of these additional platforms where you can then learn more about the context and the alerts in question. And all of that in a user-friendly and open interface. So we are funded through research projects like ACME, which allow us to make these platforms and apps for your smartphones available without cost. So there's no subscription or upfront cost necessary, and everybody is invited to use them. And then using modern interfaces, I mentioned smartphone apps. Of course, you can get then push notifications for various alerts, so you don't really miss anything. You're being up to date. And the following talks will guide you through these various ways how you can use these interfaces, how you can use the databases, how you can access that information that we collect for these time domain phenomena. And so this is a broad introduction about why we built this app. So at the first level, it was built for ourselves. So I'm responsible for the time domain observations on one of the largest gamma ray observatories. And we had to sift through that wealth of information every day to pick out the most prominent sources. So these apps help us in our own work to be more efficient. But again, once we realized that there is this connection and there is the interest in the amateur astronomy communities, the whole thing is available for free to everybody. And throughout the day, we'll hear a few examples of groups and networks using these tools and have built integrations into other platforms and tools like Prism and Nina and etc. And I stop here and happy to take questions. Otherwise, we hand it over to my colleagues who go through the details.
Thank you, Fabian. As a reminder to everyone, you can also post questions in the chat as well throughout the day.
I have a question. Can the slides be made available to everybody? Because there's lots of interesting material on all of this stuff.
Yes, that would be great if all the presenters could share their slides afterwards as well. The day will be recorded as well, so it'll be made public. But yes, the slides as well, if you could send them to me as well.
So we send them to you, James, and you put them on the website?
Yeah.
Very good. Great.
Right.
All right, if there are no more questions, Uche, if you want to take it away.
Yes, and let me share my screen.
Yes, something very formal. What is? Can we speak about resilience of the service against any national difficulties with the power alimentation?
Power limitations, you mean electrical power?
Yes, electric power. Yes, just like in Spain a few days ago. Are you still here?
Yeah, I mean the main services run on AWS cloud servers, which have a extremely good track record on uptime and efficiency. So it's 99.999% better than anything we could achieve locally in our institute. But of course, these services also go down from time to time, and then you hear it quite loudly in the media, because a lot of the core services of the internet nowadays run on these cloud platforms. So if that happens, then Astro-COLIBRI will be down as well. But typically this takes a few hours and has never happened in the last 6 years. So
Okay, thanks.
So I would say we are quite resilient.